So what if I told you that everything you think you know about gravity is wrong? Today, we are going to completely flip the script on one of the universe's biggest secrets, and we're going to do it with a really simple analogy. Get ready, because it turns out gravity isn't a force pulling you down at all. It's something way, way weird. I mean, we all feel it, right? It's that constant, invisible tug that keeps our feet planted firmly on the ground. It seems so obvious, so fundamental, but is pull really the right word for what's going on here? Because what if that feeling is just an illusion? Einstein sure thought so. He came up with this radical idea that there is no pull. Instead, the very ground beneath your feet is constantly being pushed up into you by the fabric of the universe itself. Yeah, seriously. Now, to really wrap your head around this, we need a new way of picturing the universe. So let's build that picture together. I want you to forget everything you think of as empty space. Instead, let's imagine the universe is like a giant cosmic trampoline. Okay, picture it. A huge, perfectly flat, flexible sheet stretched out tight as far as the eye can see. This is our stand-in for the fabric of space-time when it's totally undisturbed, completely empty. All right, now let's take something heavy, like a bowling ball, and set it right down in the middle of our cosmic sheet. This bowling ball, well, that's going to represent a massive object, like our very own planet Earth. And what happens the second we put it there? The ball's weight sinks right into the sheet, of course. It creates this deep, curved dent. So now, that perfectly flat fabric of our universe is warped. It's bent by the presence of all that mass. So what is this curve? It's not just some random side effect of the bowling ball's weight. According to Einstein, this is the thing we've been trying to understand all along. That simple little curve in our cosmic trampoline is the whole key. Because what Einstein figured out is that gravity isn't some invisible force. It's the actual shape of space itself. And this is a huge shift in thinking. Newton thought of gravity like an invisible rope, pulling things toward each other. But Einstein's idea is so much more elegant. He said there is no pull. Objects are just trying to travel in a straight line. But they can't, because the universe they're moving through has been curved by mass. They're just following the contours. And this, right here, is the heart of Einstein's theory of general relativity. To put it simply, massive objects literally tell space-time how to curve, and that curvature is what we feel and call gravity. So let's go back to our analogy for a second. If you roll a little marble past that heavy bowling ball, it's not being mysteriously pulled in. No, it's just following the curve in the sheet that the bowling ball made. And that path it takes, that's its orbit. It's the exact same reason the moon orbits the Earth. The physicist John Archibald Wheeler summed up this whole incredible idea perfectly with this quote. It's like a beautiful cosmic dance, right? Mass creates the curves in space, and those very same curves then tell mass how to move. It's an endless feedback loop. So, okay, this is a pretty cool thought experiment, but does it actually matter in the real world? Oh, absolutely. This isn't just some quirky theory. It is literally the blueprint of our reality. The consequences of this are enormous, and they're very real. This theory perfectly predicts the weird, wobbly orbit of Mercury, which Newton's theory just couldn't explain. It tells us why light from distant stars actually bends as it passes by massive galaxies. And get this, it's so precise that the GPS on your phone depends on it every single day. Because gravity curves space, it also warps time. Time literally runs slower for us down here on the ground than it does for the satellites way up in orbit. Your phone has to constantly correct for this time dilation just to give you accurate directions to the grocery store. Wild, right? So look, if you take away just one single thing from all this, let it be this. Gravity is not a force pulling you down. Gravity is the geometry of the universe that you're traveling through. You aren't being pulled, you're just following a curve in space-time. And that leaves us with one last, truly mind-bending question. If our Earth is like a bowling ball, making a gentle little dip in the fabric of space, what happens when you have an object so massive, so incredibly dense, that it doesn't just create a dip, but it punches a hole clean through the sheet? What happens on the other side? And is it even possible for us to find out?